hit this record button. Okay, so we're starting. So as I said, we have just the end of the chapter 2.9, and it's called Breaking the Line, Piecewise Linear Functions. So let me share my screen, and I'll show you how that works. And before I do that, does anybody else have a conflict with Tuesday's test? Does that work for everybody? So if something comes up, just let me know and we can work that out. Okay, but Tristine, you're all set. So that's good. Okay, so let me get into my iPad. I'm just going to share this screen. And I also have my calculator. So if people have calculator problems, we can also look at that. So let me share here. Okay, so hopefully this is going to be fine. Okay, let me do that and that and that. Okay, so it should switch over in just a second. Okay, good. Okay, so let me get into the notes, and let me let Alice in. Okay, so she's in too. Okay, so our notes are right here. So this should look like what I posted. So this is an example of what a piecewise linear function looks like. So you can make it out of not only just linear functions, but quadratics, absolute value, that kind of stuff. So you basically have two pieces. And so here's one piece and here's a second piece. And the way they differ is by these domain restrictions. So Tristan, do you teach piecewise functions at your school? I think she just stepped out.
Sorry, yes. We didn't used to, but when we started illustrative math, we started teaching them.
And so are you teaching it in Algebra 2?
Algebra 1 now.
Oh, you're kidding me.
It used to just be Algebra 2, but illustrative math touches on it too.
Oh, that's interesting. Oh, wow, that's surprising. So we used to teach it in Algebra 2, and then we dropped it. And so now we only teach it in pre-calc. They may teach it.
It's not like a full thing, but it's definitely now a part of
it. Yeah, I mean, they're really interesting. And from a business point of view, most of your demand functions are piecewise functions. Because if you think about like your water bill, there's different rates for like commercial versus residential. That's all piecewise functions. So if you ever go for an MBA, that's what it is. Your economics class deals with a lot of piecewise functions, and that's just because that's how businesses work. So this may be the way it initially looks, but really what they do is they do this. So they say they have one function. So here's the one function. It's the f of x. And that one function has two pieces. So they're not separate functions. They're pieces of functions that have separate domain restrictions. So what you would do to graph that, you'd say, okay, what I tell my kids to do is to use different colors. So I'm going to put green here, and I'm going to put red here. And so I'm going to do a little t-table for my green. So I pick my x and my y, and this says I have to start, this piece only works for x less than or equal to 1. So I have to start at 1. And my kids are really resistant about that. They're less resistant when it says equal to it. So I start at 1, and I'm going to say that this is closed. And I'll tell you why in just a second. So I'm going to go 1, and I have to go less than 1. So I'm going to go just 1, 0, and -1. And then I'm going to take my 1 value for my x and plug it into this piece. And that's going to give me 4. I put a 0 in, that gives me 3. I put a -1 in, that gives me 2. Okay, this function can continue to go this way. So I'm indicating that with an arrowhead so I kind of know what I'm graphing. Okay, so what you end up graphing is this right here. This is that piece. Now, the key thing is this has got to be a function. So it has to pass the vertical line test to be a function. So that means if you put in an X, you can only get out one Y. So you have to have a situation where you might have a filled in dot here. Directly below it, it has to be an open circle. Otherwise, it's not a function. So then let's plot the red. So I'm coming here. I'm doing again another little t-table. And this says for X greater than 1. Even though you say, well, it can't equal 1, you've got to start at 1. And you're going to say that this is open. And you're going to give it an open circle. The reason why you have to start there, and then you're going to continue, is because maybe you can't use 1, but you can use 1.000001. And if you didn't start at 1 with an open circle, you would miss out on a whole bunch of numbers. So that's why you have to start at the number they give you. So I have those three I just picked. What I'm seeing is that this piece is X independent. So it doesn't matter what my X is, my Y is always going to be that. And this is that piece. And here is my open circle. Okay, so from here now, they frequently want you to tell me the domain and the range. So the domain, and I'll change color so you don't think it's related to any of the functions I've done. It's independent. So the domain. So I'm going to turn on my little flashlight here. You hop on the lowest X you can hop on, and that's going to be down here. So I hop on this X, and that means I'm going to start at negative infinity. So because I can keep going to the left as far as I want to. So I start my domain at negative infinity. Then what happens next? I start going up here. So I'm going further and further to the right on X's. I then get stuck here. Because this X, well, this point and this point have the same X value, I'm allowed to slide down here and continue on this domain. So that means that my domain ends up being all real numbers or negative infinity to positive infinity. So then you're going to do the same thing with range. So range, remember, are your Y's. So range is Y and domain is X. So you're going to say, okay, I'm going to hop on with my flashlight again. And I'm going to say, I want to have the lowest Y I can get on. Well, this goes all the way down. So I'm starting here on this Y, and I can go all the way up to here. Now, my Y's are here. I have a gap here, so I can't drop down because that's a different Y. So I am done here. I can't go any further. So therefore, I finished my domain. I had started it at negative, at negative infinity, like I did my domain, but my range is going to be negative infinity up to that value of 4, and I can equal it, but I can't go any higher. Okay, so that's a simple piecewise function that has just 2 pieces, and both pieces are linear. Okay, so does that make sense? Kind of. And if you use different colors, it really does help to make it kind of pop, and you can keep track of what piece you're working on. When you do it, Christine, what do you do to help your kids since they're a lot younger?
We did this actually today, like we just started talking about without using Piecewise. We talked about, there was a problem about gym memberships and pool memberships.
Mm-hmm.
So it was really a linear system.
Right.
Talked about how if you get like 3 and under in some places, then it's one price. And if you have 4 plus, then it's a different price. And so we didn't actually go into Piecewise, but like we're starting it because that's the discussion of depending on how many memberships you buy and group discounts, all of that, that you get one line for one thing and another. So we've opened the discussion before we started the graphs.
And so
And
you can tie that right into slope the way you introduced it, right? So that's
Yeah.
good. Yeah,
Mhm.
because it comes up. I mean, that's a classic case. And those
Right.
are the cases that people are so familiar with. That, your rates on your cell phones, they're all piecewise functions. And it's one of those things we never really get to, although it makes complete sense to discuss it. And what does it mean if it's a function? If it's a function, you can't violate the vertical line test, so you have to set it up a certain way. And the slopes are different depending on what group you're with. So yeah, I think that's really a good way to do it.
I
And it
like, and
kind of
that's
fits
the
in
part,
nicely.
that's the part of this curriculum that I do like, is they do use real life stuff all the time.
Yeah,
So like with systems, it's about, it costs $15 for 2 different items. And then if you bought 2 pounds total, how much? And so it goes into things that they would actually buy and like that kind of stuff. So that instead of if train A left Maine and went to San Francisco, like how
right.
we did everything. Yeah, it's not like that. It's like real life stuff.
Yeah, yeah. And then they go to the stores and they can actually apply their math skills to it. Yeah, I think that's very good. So there's another one here that they don't give you an equation. You kind of have to figure it out yourself. They just want you to have a handle on the graph of it. So if you read this, it says, okay, consider the amount of gas in your car during a road trip. You start out with 20 gallons. So what they're looking for is this. So you have gallons of gas here. So this is gallons, and this is going to be time in hours. And what they say is you start out with 20 gallons. So here you have your max of 20 gallons. And then you're going to drive for 3 hours. And they don't discuss how you drive. You can kind of be as creative as you want to with that. I'm going to assume that you're driving at a steady rate. That's going to leave you at the end of the 3 hours with 14 gallons in the tank. So I'm going to go by like 5. So this is 15, 10, 5. So if we started out here, that would be my first point, and it's going to be filled in. And then as I drive, I'm going to drive for 3 hours. And that means that I'm going to stop driving when my tank will be at 14. So I'm going to make that an open circle because I'm no longer driving at 3 hours. That's when I'm stopping. So here's the first little piece. Without really having an equation, I could have gone different ways. I could have been decelerating, accelerating, but I just kept it simple. So then they go on and they say you stop for lunch for an hour. So I think this is kind of interesting because time passes, but you're not going to have any evaporation in your tank. So therefore, you just have a straight line for that 1 hour. So then you're going to start to drive again for 4 more hours after you've had that lunch. So I would say that here you're going to start to drive again. And this time when you're done, so 4 more hours is going to take me to 8, 4, 5, 6, 7, 8. I'm going to only have 6 gallons. So I'm going to be about here when I stop. And there is a piecewise function. Okay, so it's not as fancy as the other one where we had a definite equation, but yet you can see that you don't have a linear function. You have 3 unique linear pieces, and one of which has a slope of 0, right? Because you're not burning any gas. And the other 2 are linear functions that have downward sloping graphs because it's negative because you're losing gallons as you drive. So that's just a little example of how you can think about piecewise. And really, this works for kind of any level of student. You can talk about driving and what's in the gas tank and that kind of stuff. So that's your little introduction to piecewise. And then we're going to do some more piecewise. There's another function called absolute value. And absolute value, the parent function kind of looks like this. So if you have an absolute value function, it's going to be a V for victory. So what's happening is, so that's your absolute value parent functions starting at the origin. So this is my Y values equal the absolute value of X. And absolute value of X means that you drop the sign. So a lot of times my kids will say, well, they're all positive. Well, technically, absolute value is the distance from the origin. So it's really neither positive nor negative, but that's your absolute value function, because no matter what your x is, your y will always be on this part of your axis. Okay, so that's how that works, and that's just absolute value. Okay, let me let Annie in. Okay, so in terms of using it, they're saying, okay, if this is your value, your absolute value, and you drop the negative, this is going to be your answer. So that's just, I wanted you to know about absolute value. You can shift those functions around. Here is an example of the setup. So they broached it as a piecewise function, which you can think of it like that. You can think of this absolute value parent function as a piecewise function if you say that if the function, if f of x, if x is greater than or equal to 0, then your y value is x. On the other hand, if x is less than 0, your y value, oh, excuse me, if negative x is present here, that's occurring when x is less than 0. And since you're dealing with absolute value, you'll just drop off the sign. So you can use those negative x's, but when you do, you use them as an input, your output's going to be the absolute value of it, which puts you back on this curve. So that's kind of all I wanted to say about absolute value. We never really think of it as a piecewise linear function, because we've taught piecewise, now talking about parent functions, and we never make the connection between absolute value and piecewise. It tends to not be handled that way. So that's the second thing. So if they ask you questions about absolute value, what you need to know is that if you put in a 6 for your x, remember when you evaluate, you're replacing your x, and then you're generating a y, because x always drives the train. So if this is your function, and I say evaluate that where f is 6, I would say, okay, f of 6 equals the absolute value of 6, which is 6. If I'm going to evaluate it at 0, I say that equals the absolute value of 0, which is just 0. And then lastly, if I want to evaluate it at negative 6, that equals the absolute value of negative 6, which is 6. So if you graph that, you'll see you have the parent function. Okay, so that's it for that. I'm not going to really ask you anything else about that. And then the last kind of function is the step function. So a step function is kind of interesting because it you have horizontal pieces, and then once you go over a certain limit, you jump up. So for example, if you were to plot this, and you would say, okay, I'm going to plot these values. And so on this side, I have my hourly wage. So this is my wage. And this is going to be time. And so I say, okay, this is 1997. And then let's just say that this is 2000, and then they're going to be much closer. So I'm not really spacing this very well, but you get the general idea. So in 1997, from that time, so I'm going to start at 1997, and that wage was $5.15. That's going to hold all the way to here. The second I cross over into January, I'm no longer on this function. I'm then going to jump up, and this next function would be 585. So I'm going to be up higher. I'm just going to fill in the circle, because now you're in January of 2007. The next rate takes over. That's going to come up to here. But the second I get to 2008, I have an open circle again, because I have another rate coming in. So the next rate is going to be even higher. So it's going to be 655, and that means that up here I'm going to have a filled in circle because here comes January with a higher rate. And that's going to only be in play until January of 2009, which gives me another open circle. Then I'm going to jump again, and I have 725. At 725, that kicks in at 2009. And so I'm going to come up here with a filled in circle because now it's January and that rate kicks in. And I don't have an end for that. So I'm just going to go like that and say that it's going to continue until some federal regulation kicks in and makes another rate. Okay, so that's how hourly wages actually work. It's not a gradual thing. These are jumps. And the jumps are functions because of the way that they kick in. You never have two prices at one time. If you had two prices at one time, you'd be generating two Ys for one X, and you can't do that. And that's why it's a classic piecewise function, or a classic definition of a function. So, and then I think we have a couple of other things here. There's another piecewise function that we can graph, and then there's something called the greatest integer function, which is another kind of step function. So it's almost identical to this situation, but we'll talk about that as well. And then we have some evaluating to do, and I wanted to go through that also because that's a big part of math, is knowing how to evaluate things and knowing what the rules are with these absolute value functions. Okay, so if I'm going to look at this, why don't we just, let's see, we'll do, let's do this one, because I think this one's a little bit more interesting because you actually have lines as opposed to just, you have lines that are not horizontal. So let me just point out the first one, F, what's going to happen is your Y will be a horizontal value of 2, regardless of what value you have for X. As long as you're in that domain, your Y will always be 2. And if you move to the next domain, your Y is always going to be 1. So let's try to do the other ones instead. So I'm going to use my color system again, and I'm going to say, okay, this will be green, and this can be red. So I'm going to do a little t-table. I'm going to do the green first. I'm going to read what it says because I want to get my X and Y values so I can plot them. So it says that piece of the function will be X plus 3 if X is less than 0 and if X is greater than -4. So go to -4. This is called like a sandwich inequality, where you have -4, then I have -3, -2, -1, and 0. Those are the numbers I'm going to be evaluating and figuring out what the Y's are. Before I go further, I'm going to say, okay, X has to be greater than 0. It can't equal it, so that's going to be an open circle right there. Then I look at the next piece of it. X has to be, oh, I think I looked the wrong way. Right, X has to be less than or equal to 0. So, excuse me, it's going to be a closed circle there because I'm allowed to equal it. So right here, this is closed. But then on the other side of it, it says X has to be greater than -4. This is an open circle because I can't actually equal -4. So take your X values and plug them in here. So -4 plus 3, that gives me a -1 for my Y. -3 gives me a 0. -2 gives me a 1. -1 gives me a 2. And 0 gives me a 3. So I see I have a nice linear function going on there. I'm going to plot that in a second. I'm going to move on to my red. And here's my X and here's my Y. And this is in effect when X is less than or equal to 4. So I'm going to start out with a 4. That's going to be closed because I can equal it. And then I have to say X has to be greater than 0. So 4, 3, 2, 1, 0. And this one is going to be open because I cannot equal it. Okay, so I'm going to do the same thing. Plug in your 4. 2 minus 4 is a -2. 2 minus 3 is a -1. 2 minus 2 is a 0, 2 minus 1 is a 1, and 2 minus 0 is a 2. So now I see kind of what my range is. Okay, my x's will go from -4 to +4, and my y's are pretty small as well. So I'm going to give myself a little graph, and I want to make sure I have enough room for all these numbers. So I need to go from, this is 1, 2, 3, 4. So this is -4, and then 1, 2, 3, 4. That takes care of all of my x's. And then looking at my y's, my high is 3. 1, 2, 3. And my low looks to be -2. So only plot kind of like what you need to plot. So looking at that, I'm going to do my green first. So I'm changing my color to green. I'm going to plot the point -4, -1, and that's going to be an open circle. So I'm going to plot that right there. Then I'm going to plot -3, 0. Everything else is filled in. -2, 1. So that's going to be right here. -1, 2. And then the last one is going to be closed also. So that's going to be nice dark filled in. I'm going to connect those points because my function is just linear. So you always have to look out because they can use a parabola too. And if that's the case, you're not going to draw a straight line. So here's my first line. I'm now going to change over to red. And my first point says 4, x is 4. So there's my 4 over there. And y is -2, and it's closed. So that's closed. Then I have 3, -1. So that is 3, -1. And then I have 2, 0. So that's here. I have 1, 1, which is here. And then I have 0, 2, which is here. And it's open. So this is what my function looks like. Okay, so I'm stopping at both ends. It doesn't go forever and ever because those constraints, that domain restriction is sandwiched. It's not, one-sided, it's two-sided. So then I could talk about my domain and my range. So domain is just x's. So I hop on here, but I can't really equal that. So I'm going to put that down with a paren. So that's going to be paren. I'm going to go low and I'm going to try to go higher. So let's see where I can go to. I can go x, 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 and then this is the same x. So I can travel down and then continue down here. And that's where I'm going to end at the other 4. And I can equal that. So I have a box for that one. Okay, then we talk about range and turning on my little flashlight thing again. The lowest value I can get to on my y is a -2. So that's right here, and I can equal that. So I can use my box, and I can say that that's a -2. Then let's see how I can go up the y. I can go up the y to here, and now I could have a problem, but look, this is the same y. So I'm allowed to go like this, and then I can climb up to here. So I actually can end at 3. And I'm allowed to equal that, so that's my range. So that's how that works. Okay, so you should be able to get domain and range for both of those. I'm using interval notation to do it. So just to clarify, this notation right here is called interval notation. And then this notation here kind of falls under set notation with the inequalities. So this type of notation is a little bit more advanced, and that's what we tend to use in math. Okay, so I have one more function to graph for you, and then I do have some more piecewise functions we can practice. I'm going to put a piecewise function on the test, but I'm going to tell you that it's going to be a bonus. So it would be good to know how to do it, because then you have a little cushion in case of something else that you don't know how to do. Okay, but so that's how I'm going to handle piecewise functions. Okay, the greatest integer function looks like this. It's just y equals, and it looks like this with the x in the middle. So what that means is, if you have a greatest integer function, it operates like this. If your x's are down here, so it says that as long as your x value is greater than 1 or equal to 1 and less than 2, your y value is going to be some number. I'm going to just say it's going to be 1. Once you get to 2, though, that's no longer the case. So you're going to jump up then, and you're going to start another 1. And then as you go along, when you get to the next integer, you're going to jump again and go higher and go across. So it's a step function, just like the function that we talked about with the minimum wage. Same idea. Okay, so that's really all I wanted to say about it. So the greatest integer, a function, and that step function with the wages was the same. Then I wanted to make sure that you could work with absolute value. This is the symbol. So on your calculator, this is under math, if you ever wanted to recreate that symbol. So the absolute value of -2, you should say is what? When you takers, Trish, absolute value of -2, just drop the sign and you get a
2.
2. And then absolute value of 6, just drop the sign and you get a 6. Now, when you do math, PEMDAS tells us to do things inside first. So this math is getting me -2. But when I drop the sign, it gets me a 2. As opposed to this next problem. These are not the same problem, even though they have the same numbers. So this is the absolute value of 3 is 3. I'm done doing absolute value. And the absolute value of 5 is 5. But my answer is a -2 because I no longer have an absolute value piece to evaluate. Okay, and then looking at the next one, the absolute value of 3 is 3. When you pull it out, you've got a negative hanging outside. It still gets applied. Times, now you have the negative inside. That negative drops. So that's going to give you a -15, and we're done. Okay, so that's just evaluating using absolute value. So don't think, oh, it's absolute value, nothing's going to have any signs. That's not necessarily the case, because these are two classic problems that involve absolute value, but yet the way it's structured, you still get a sign for your final answer. Okay, so that's what I wanted to cover in terms of the instruction for piecewise function. Then I wanted to do some of them. So why don't we set that up now? So I think I posted this. It's this one. Is it this one or is it? Yeah, it's this one. So it's this one. So I just wanted to do a couple of these. So was this posted? I don't want to get off and look. Yes. Okay, so why don't we try to do them? So I'll do it, but I think I'm going to put you in groups and see if you can figure out how to do it. So get me a graph for that first one. I'll put you in groups, but you're allowed to come out and ask me any question you want. And then what I'll do is I'll be doing it as you're doing it, and then we can compare answers. Does that seem reasonable? So let me stop sharing here. And let me do this. So I wanted to tell, so Annie and Alicia, what I said was, I don't have a lot of material to cover. Like I've now pretty much covered it. I want to do some more practicing, but I wanted to give you the opportunity to ask me questions for the quiz, the test coming up. And what I did was I kept the last couple of years questions. So I have some of those that I can, propose for you and see if you want to practice them. So that's what I wanted to do today. So it's a good time to ask questions. So let me
Thank you.
just
Sounds good.
put you in groups. Let me just see if this is going to work. Now, where did that go? Okay, so let me close. I know what. Let me close this. Let me close that. Yeah, here we go. Okay, so let's see. Why don't I just do? I'm just going to do 2 breakout rooms. So you're going to have about 3 people in each one. So the rooms are open, so you can hop in, and then I'll close it in a little while. I'll do mine, you do yours, then we'll compare notes. Okay. So go ahead. Okay, so let me hop on sharing the screen again.
Today. Yeah. I find the head or a ball. No, together.
Okay, so this is what mine looks like. Does that, let me just get this done. Does that look like what you have?
No, I'm a little off.
Okay, that's okay. So where are you a little off?
I think I went up a little higher on the blue. Let
Well,
me,
is it because you just used more numbers than I did?
oh, that could, well. Yeah. It's similar, but it's just a little off. It's not.
Because as long as it's a line that's parallel to mine or that's on top of mine, you're okay. I just stopped it after I only picked three numbers and then I just sketched it.
Okay, all right.
Because once you see the pattern, because remember, it only takes you a couple of points to draw a line. And then once you have your line, you're good. And then this guy here, you have to have it so that you don't have a filled in on top of a filled in, because then it's not a function.
Okay,
So this has to, if you're gonna have things that are on top of each other, it's okay as long as one's open and one's closed, or both are open. You just can't have them both closed. So then the other thing is they can't cross either. Because if they cross, so in order to have it be a function, it has to pass the vertical line test. So that means if you draw vertical lines down your graph, it can only hit the function, and really the function is both pieces one time. So if I were to draw a vertical line, like if I draw this vertical line, it's only hitting the blue. And then over here, this is empty, so it's not really hitting this. It's only hitting the blue. And then beyond this, I only have green. And then on this side, I only have blue. So it doesn't violate any rules of functions.
Okay.
So that's how that works. So my other group, how Trish, is that good for you too? Did you have the same similar things?
Yes.
Okay, great.
Well, we didn't get to figuring out the domain and range, but
Okay, so
the graph
so
looks good.
that's okay. Let me explain the domain and range. So it ends up being all real numbers, because if I do domain and I try to hop on the furthest X I can, I'm out here, and then I'm coming down, I'm still going to the right on X's. I get to here and I appear to be stuck. However, this X is 2. This is also 2. I can hop on here and then continue down here. That's how I went from negative infinity to positive infinity. And then with the range, do the same thing. I'm going to start way down here where this arrowhead's taking me, and I come up and I kind of get stuck. But since this is the same Y value here, I'm allowed to slide over and hop on that curve. And that gives me negative infinity to positive infinity again. So that's how I got that. Okay, I thought we just do one more, and then I will see if we have questions on other things. So let's look at this one. It has 3 pieces. So it's not that complicated once you start plotting it, but no, you're going to have to do 3 little t-tables. So we'll do the same thing. I'll do it, you can do it, and I'll pop you in whatever rooms. They may pick different rooms, they may pick the same rooms. I'm going to say recreate. And then I'll say, okay, so it's probably going to be the same room. So just hop into your room. We'll get that done. And then we'll see if we have problems, if we have questions to discuss about the test.
Stop, girl. Stop it.
So they're going to need you, Tristan, so hop off. Recording. Okay, so then I'll share my screen again, so when they come back, they can see it. Okay, so we chatted over with the other room, so I wanted to pull you guys back and see how you're doing and show you what I have and let you compare your work with my work and see what we think.
I had a question, but looking at your work, I was wondering if, because you were saying that the lines or the segments couldn't overlap,
Right,
the points
they
do,
don't
you can
actually
do one-
overlap. What's happening is,
It's an open and a closed.
yes, so
Okay.
the blue function fills in the left part of the green. Then the red function, or the red piece of the function, fills in the open circle for the green. So the green has two open circles, and that's what allows it to be filled by the others without violating the function rule. If they were both closed, then you couldn't do that. But that's how you represent it. So put the open circle around the closed, and then you can see which one's open and which one is closed. And then your domain ends up being all real numbers, but your range can't get any higher than that 0. And because the red function fills it in, you're allowed to equal that 0, and that's why I have the bracket. So I think doing it with color really, really helps, because then you can see what function or what piece of the function is doing what, especially in terms of opening and closing. And then you can kind of have it tell a story. It's good practice too on lines, because you have to say, okay, well, what is this? Well, this is a horizontal line. It's a y equals line. Here's the slope is 1, and your y-intercept is -2. Here your slope is -2, and your y-intercept is +4. So for that function, the slope is positive. For this one, it's negative. So this is going this way. This is going that way. So this is a positive slope. This is a negative slope. This is a horizontal line, which has a slope of 0. There cannot be any vertical lines, because a vertical line would violate the function rule. So you don't have any vertical lines. If you did, they'd be x equal lines. So that's a little bit of, built-in line review. So what do you think about piecewise functions? Now you've seen a couple of them. So I think the best approach to them is you have to be really systematic. And if you do these little t-tables, having this information as to what's open and what's closed is really important, because we tend to just plot these points without looking back at the inequalities. So if you give yourself information here, the chance of you forgetting that you have open and closed situations is less. So I had, well, I guess why don't I just open it? I don't necessarily want to do any more piecewise functions. I think we have the gist of it, because I like to make sure that you can ask me questions on other things, like the lines, for example, or getting equations so that you have a y equals, calculating slope, the difference between parallel lines and perpendicular lines, writing lines was important. Talking about concavities, and then any of the data stuff, any of the charts. So anything at all. So do you have anything that you wanted to talk about or ask questions on? If you want to look back at your problem sets, I have them both here. So I'm happy to field anything there as well. I tried to write out if there were errors for the ones that I've graded. If there was anything amiss, I tried to write it out for you, but I'm happy to answer questions. Any takers?
I have a question just in general about the format of the test, or like, is it something that's like we're answering online, or is it kind of like the problem sets where we could print it out if we wanted to and write on it?
Yes, you can definitely print it out and write on it, and then just scan it back in, because I think it'd be really hard to do it any other way. So
Right.
yeah, feel free. When you see it, you can print it and then just scan it back into me.
Okay.
Okay, so it's not a timed test.
It's not closely timed. Like I figured it should take you no longer than our regular class time. So that's like an hour and a half.
Hmm.
So that's what my guidelines would be for you.
Okay. So it'll open at 6 and we have like an hour and a half? Is that how
Right.
it'll work?
Like I'll probably say, like I'll give you 2 hours because if something were to happen in between, then you still be fine. And if any disaster, befalls anybody, just call me or text me and I'll be able to, help you out. So is there anything that that's a point of confusion? Are we okay with all the different forms of a line? So for example, so you've got like 3 main forms of a line. So the form that the kids are usually the most familiar with is y equals mx plus b. But there's also y minus y1 equals m times x minus x1. And that's a really good form because it's super easy to work with. So m is slope. The b is the y-intercept. Let me just hop in here.
For the second one you wrote, is that one point slope? I forget the.
So the second one, so this is point slope, exactly.
Okay, okay.
So that's point slope, and this is slope intercept. And then there's a third form of a line, and it's like this. And that's called standard form. And a lot of times we'll use that to graph, because you can set your x equal to 0, solve for your y-intercept, set your y equal to 0, solve for your x-intercept, and take it from there. So you have 2 points to plot, and then you're set. Okay, how are you if I tell you that if I phrase something like you have 2 points, so 1 and 7 and -3 and 2, and I want you to give me the equation of a line that those 2 points are on. Do you have a sense of how you want to do that? So you have to get the slope, right? Because I didn't give you a slope. So you're going to say, okay, I have to get the slope, and the slope is y2 minus y1 over x2 minus x1. So it's a good idea to label your points if you find this at all confusing. So then your slope is going to be, so the way I have it set up, it's 2 minus 7. And then I go back to my x2, and it's -3 minus 1. So that's going to be 2 minus 7 is a -5, and -3 minus 1 is a -4. So a negative over a negative is a positive. So you would say your slope is 5/4. So that means if I said to you, okay, I want the line in this form, you currently have this. So to get your y-intercept, what you would do is take one of the points. So let's say I take this one and temporarily plug it in for the x and the y so that you can solve for the b. So 7 equals 5/4 plus b. Okay, so I picked yucky numbers. So I'm going to make this 28 over 4, which is equivalent to 7. I'm going to subtract away the 5/4 to get my b. So that's going to be what? 23 over 4 is my b. So my equation, I need it to be in this form. My slope, I said, was 5/4. Put this back in generic, and then add your 23 over 4. Now you have it in point slope form, or in a slope intercept form. What if instead of giving you points, what if I gave you a graph? So what if I said it was like a grid, this little T table that we had? So what if I say I have the following numbers? This is equivalent to giving you points, but it's just a different presentation. So let's say that we have those numbers. And I say, I need you to give me the equation of a line. So do the same thing we did. Get your slope by saying change in y over change in x. So I'm just going to say 7 minus 2 over 1 minus 0. So that's going to be 5 over 1. So my slope is just 5. Now they gave you a gift here because that is your y-intercept. So if you see the gift, you can say, oh, thank you so much, because now I have that and I'm done. How are you at graphing? If I gave you this, we tend to graph the following way. Start at your initial value, which is that 2. Go up 5, 1, 2, 3, 4, 5, over 1. That gives you your second point, and there is your curve. Okay, that's your line. So I think we talked about parallel and perpendicular lines too. So big thing about them. So parallel lines, if lines are parallel, they look like that. So they have the same slope. But if lines are perpendicular, they look like that. And if this slope, say for example, was 7, this slope, the perpendicular slope, has 2 changes. It's a different sign. If that's a positive, this is a negative. And it is the reciprocal. So it's going to be negative 1/7. That's how you relate parallel lines. If this was 6, this is 6 versus perpendicular. Let me just look at the test and see if there's anything that I want to make sure that you know.
Is the test open note, or should we not use anything?
You know, since I really can't control that,
Right.
it kind of is.
Okay.
If I was in a classroom situation, I wouldn't, but I don't, since I cannot enforce it, I just say, you know, I just can't enforce it. So there's that. I mean, I don't want to lock you in. I don't want to put a camera on you, those kind of
Right.
things. So in terms of what's on the test, so you have to know like the graphing stuff. So can you read a graph? So you want to look at the y and x and, you know, see what the data is. Can you answer questions about a graph? Can you draw a graph? If I give you the data, can you make like the frequency graphs or the bar graphs or the histograms? So remember, histograms are touching. That's what makes them different than bar graphs. You should be able to make a pie chart as well. And that's just based on percentages. What else? We talked about how sometimes you can misrepresent data by changing kind of the scales. And so you want to be aware of that and be able to kind of talk about that. in some of the problems, I think we had a situation where I gave you, let's say, 5 test scores. And I said, I want my average to be whatever. Find the 6th one that's going to help me to get that average. So be comfortable with those kind of problems. If the type of problem was not on the problem sets, we won't do it on this test. Okay, so if you've seen it on a problem set, then you can expect to see it here, because I wanted you to practice that so that we can then test for it. In terms of what we covered tonight, things that could be on it, I told you that I'm going to make the piecewise function a little bonus so that you have some other little, cushion in there. So if something else is confusing and you understood the piecewise, or you're willing to try to tackle it, you can have a little cushion there with points. You want to know how to deal with the data. So remember, we put it into the graphing calculator to figure out the mean, the median, and the mode. So we did that, and we put it in L1 to figure that out, and then we just could calculate it. I posted the videos of our classes, so that's up there too. I gave you data from that. We made frequency tables, and then you can graph it from there. Oh, one thing that is always good to practice, if you have like a long string of variables, and let's say you have like a y plus 7x minus 3x plus 14 minus 2y plus 7. Could you get that into a y equals equation? So you want to have the y's on one side and everything else on the other side. So everything is on this one side right now. So you'd have to do some moving. When you move, well, the first thing you want to do probably is combine like terms. So in this scenario, I would say, okay, I'm going to add my y and my negative 2y. That gives me a negative y. I'm now done with those. Then I'm going to have my 7x and my negative 3x. If I do these two together, that's going to get me a positive 4x, and I'm done with that. Then I have numbers left, so, and they're both positive, so that's going to be plus 21. So that's what I have. So if I want this to be an equation of a line, that means I want it to be a y equals. At this point, to move it over the equal sign, you have to do the opposite operation. I haven't done that so far because they were all on the same side of the equal sign. So when I do that step, they cancel. I then have to do the same thing on the other side. My end result is that I get this equation. Okay, so always take care of the things that are on the same side. And when you take care of them, what you're going to do is combine like terms. So you can't combine numbers with variables because they're unlike terms. And that's why I kept the 21 separate. But I could combine the 7x and the negative 3x. And because they were on the same side of the equal sign, I did not change their signs. You only change the signs when you're trying to cross over the equal sign. Okay, oh, the other thing that I wanted to mention, like reading a graph, you know how a lot of times they'll give you numbers and they'll say, oh, those are in tens of thousands or those are on millions. So when you report that data and talk about it, put it in those millions or tens of thousands. So if my range on my y-axis was 1 to 5, and I said that was millions, and I asked you what the value is when x is 1950, and you say 2, that would be incorrect. Okay, you would say 2 million because that's actually what you're reading. Okay, so I did that also in the homework, in the problem set. Evaluating numbers. So if I said, okay, here's my function, so I'll write it in function notation. This is function notation. And if I say, tell me what f of 0 is, what you would do is you take every x and replace it with 0 and then solve. So f of 0 would be 21. So that's evaluating. So we did some of that as well. Concave up, concave down. This function is everywhere concave down. Okay, this function is everywhere concave up. So if you think about up looking like this, it's concave up. And then we talked about where functions are increasing and decreasing. So if I gave you a parabola, and let's say I have it centered around here. So here's my parabola. Parabolas go on forever and ever. And let's say this is a 7. If I said, tell me where the function is increasing. So it's increasing, that means your y values are increasing from negative infinity all the way to 3, because you're going to read your x values. But at 3, it's neither increasing nor decreasing, so I use a paren. Then it's decreasing from 3 to positive infinity. So this side is increasing, and then this side is decreasing. And when you use this notation, it means that when you're actually at the 3, it's neither decreasing nor increasing. It's kind of a steady state. And that would be concave down. Yeah, I did talk about perpendicular and parallel lines. So when I did something similar for my kiddos in my pre-cal class the other day. So if I say, I want you to find an equation of the line that is perpendicular to x equals 7 and goes through 1, 4. Okay, so if you think about that, the first thing I would do is draw that line x equals 7. So here's my xy axis, here's my 7, and here's the line x equals 7. So this doesn't fall into like the point slope y equals mx plus b or standard form. These are y equals lines and then also x equals lines. So that's a vertical line. If I want to find the line that's perpendicular to that, and it has to go through the point 1, 4, has to go through that point and be perpendicular. So look what it is. Going through that point, perpendicular, forms a right angle. That's a y equals 4. So it goes through that number. If you draw it, I think you're going to see it. You can do the same thing with parallel. What if I say, I want a line that is parallel to y equals 4 and goes through the point 3,5. So there's y equals 4. The point 3,5 is going to be right here, say. It has to be parallel to it. That means it has to have the same slope or slant. So that's going to be the line y equals, it has to go through 5. Okay, so when I ask you about those kind of lines, just sketch them. X is vertical, X equals our verticals. Y equals, when it's Y equals just a constant, it's a horizontal line. That slope is 0. The vertical lines have an undefined slope. Oh, the other thing we did that I didn't do in my classes at Good Counsel, but that I did with you guys, is if I have points, so let's say I have 1, 4, and I don't know if this is going to work out, but we'll see, and 2y. I want to figure out what y is if I want my slope to be 4. Okay, so if I want my slope to be 4, and these are your coordinate pairs, what you would do is you'd say, okay, y minus 4, that's changing y, over 2 minus 1 has to equal 4. So 2 minus 1 is just 1. So far I have y minus 4 has to equal 4. Isolate your y. I want to move the -4 to the right. So I'm going to add 4 and add 4. So that's going to be y equals 8. So that means if I were to replace that y with an 8, I would get the desired slope of 4. Okay, so I think I covered all the main things that I'm seeing on this test. So is there anything else you want to chat about? Because I could do this until each one of you fell asleep, but that probably would not be good.
Will average rate of change be on it? Is that included with the like graphs and data that you were mentioning before?
Yes, I talk about average rate of change, so you want to know what that is. So average rate of change is really the same as a slope. Okay, so we covered a lot of territory. So were any of these comments helpful? So I would look back over your problem set. I think that's probably the best thing you can do. Because if I didn't really test it on a problem set, I'm not going to test it on the test. So that'll help narrow your focus. But if it's on
Okay.
the problem set, I wouldn't think, I hope she doesn't ask this. Because that's just going to make you nervous going into it. So if you find that you have some more questions and that you just wish that you would have asked something, or you didn't realize something was confusing, so we hung up, that's okay. Just text me and we'll figure it out.
Okay, so the problem set 1, it's like pretty much what's on that set will be on the test. Like
Yeah,
those topics.
So there's 2 problem sets, 1 and 2. I'm not going to
Okay.
ask any questions about any of the articles. I'm just going to focus on the mechanics of the work that we did in the problem sets.
Okay.
So definitely know how to graph, know how to, do a frequency chart versus a histogram. Be comfortable putting data in your calculator so that you don't have to do everything the long way. And you have a calculator. Always a good rule of thumb. And I think that's it. And then just relax and enjoy the process. But the questions are all different than what they were on the packet. So no matter what, you're still going to be applying that knowledge to a new situation. And that's why I'm comfortable saying that I don't need to lock everything down, because the problems are new problems and you have to apply what you know to that. And given the fact that you don't have like the rest of your natural life to finish it, you've got to be able to have a good handle on it going into it. Otherwise, you're just never going to be able to finish. It's not exceedingly long, but you've got to know your material well enough to be able to tackle the problems within that time frame. And I'll post this class also. So I'll have that on, once it loads, I'll put that up on today's date. So if you wanted to go back and look at anything there, you could, if you wanted to see more about piecewise functions or whatever. See if you can figure out piecewise functions to give yourself a little bit of a cushion. Because I'll give you partial credit on that anyway. And it's not that difficult, and it's kind of fun to do, my humble opinion. But to see what you think. So anything else that we can chat about at this time? It's right about 7:30 now. So just let me know if you have any worries. Otherwise, I'll probably open it on Tuesday a little bit before 6. Like I'll probably put it up at 5:30, truthfully. And then I'll give you an end time. That'll be probably like about 8 o'clock. So you'll have some additional time to do it. And I'm going to do Tristan's on Monday so that she can do her other back to school stuff. And then do we meet next time? I'm trying to think what. No, I think next time, I think we're going to start chapter 3 with a video. And then we'll do that. So just keep up on what's due when. Let me just see if I have anything for you to give you insights. So we're going to have our test on the 17th. And then we're going to start with a video on the 24th that will start then chapter 3 for us. Chapter 3 is all about linear systems again. So it's not that long. And we'll have that done in probably 2 classes. And then we'll look at the test for that.
And then it says that the appreciation paper is due that week after the test, right?
Yes. So the reflection paper number 2 is due.
No, the appreciation paper.
Yeah, that's what appreciation paper is due class 7.
Okay.
Yes, so that's the same day as that video class for chapter 3.
Could you kind of go over what you expect from the appreciation paper? I was trying to look at it on the syllabus and I was just a little confused as to what exact topics you want us to look at.
So it's kind of a history paper. So you're going to look at the history of algebra. So you're going to find a chapter in that book that pertains to what we're learning now. I think there's 1 or 2 of them that talk about algebra. Then they want you to have other sources as well. So you want to pull in other sources too. So just follow that rubric, because I'll use that to grade. So they say, so let me just grab it right now. And I'll tell you exactly what we're looking for. So I'm going to look for your other references. Let me get this.
And do you want those other references submitted like you do for our second reflection
No,
paper?
you can just
Okay.
add them to your the end of the paper
Okay.
as your references. Okay, so what they want you to do for the appreciation paper should illustrate a broad overview of the topic selected. So it should be pertaining to our class. It could be a little bit of a stretch, but as long as it's, within the realms of algebra, you're good. Illustrate how this development, so whatever developed, okay, they want you to think about the historical context. So place it in history. Where does the article talk about history? What are people doing? How are they experiencing the math? You can compare it and contrast it to what your experience with the math is now. And illustrate how this development in math fit in with other human activities of the time. So it's all about the historical context. And then you can talk about whether any problems with that development of the concept. Were people against having math used in that regard? And then it says, include at least 2 other references besides the history text. It's not that long, it's like 4 pages. So if something like, say, for example, if you were doing, counting and the whole concept of counting, and then they had to, have a 0 in there in case the herd died, they have to be able to say they had none. So what was our historical context? Are you in like the Middle East during this time? And then if you think about that, you think, oh, maybe a tangent to that would be other methods of counting that maybe aren't the way we they were doing it then. So then you kind of Google, look for a paper that talks about different counting methods and how they're taught in school now. And then you can kind of pull on the historical that way. Okay, does that help a little bit? So put it in time. Where are they discussing it? How is that kind of interesting? How are they experiencing the math? And what other things can you relate it to? So you do not have to talk about anything with the standards. Okay, so this is not a standard based. They're really asking you for a succinct overview, the placement in historical context, and the discussion of problems and consequences. So that's it. And then, you know, organize your paper. You have to have an appropriate topic. So you couldn't say, you know, write a whole paper about the emergence of pre-calculus when we're not doing that at all. So that's it. I'm going to grade it with a rubric. So when after you write it or as you're writing, you think to yourself, okay, am I hitting each of those little points? And if I am, I know I'm good. If I've missed something, I need to kind of, you know, revamp it a little bit so I can include the points so I can get the most points for every category. Okay. Okay, so hopefully this helped. So if you need any more help with this stuff or need to, you know, go over anything else, just reach out and we'll make plans to either talk on the phone or do a Zoom type thing to get you ready. Okay. So Annie, just keep me posted, okay? About your stuff. If I can be of help, let me know. So hopefully
Okay.
some of this helped some of those problems. But see what you think. Okay. Well, I'm gonna let you guys go because my dog would like to go out now. He can always tell when things are kind of like winding down because he was just napping and now he's up and wants to know why can't we go out, right? Yes. So let me run, let you run. But good job tonight with the group work with the piecewise functions. I thought that went really well. And I'll post this as soon as it loads, so you'll have this to go on as well. Okie doke. All right. So until we meet
Thank you.
again, have a
Thank
good
you.
evening.
Bye.
Yes.
4x, and then it jumps up to, and this
Let me stop that. Okay, good.